Alright, for today's lesson you're going to work on graphing linear inequalities. So remember, inequalities are problems that involve these symbols, the less than, greater than, less than or equal to, or greater than or equal to, and they don't deal with the equal sign. That's just a regular equation. We're going to work on graphing these inequalities. So linear inequalities have boundary lines, which is the line on the edge of a graph of a linear inequality. The solution is a shaded region that makes the inequality true. So remember when we worked with inequalities, the symbols for less than and greater than had like the parentheses or the open circle, and then the less than or equal to had the brackets or the closed circle. There's one more symbol that works with them. When you're graphing inequalities, the inequality less than or greater than just has a dashed line, and the inequality less than or equal to or greater than or equal to has a solid line. So we're just adding one more notation with them. To graph linear inequalities, you do the same steps as you would with an equation, but now you're just going to do some shading, and then you're going to use either a dotted line or a solid line. So let's look at the two examples on the bottom. When you graph linear inequalities, you graph the boundary line, and then you shade above or below the boundary line, depending on the symbol. So, for my first example, I have y is greater than or equal to 1/2 x plus 2. Notice this is the format that we're used to in terms of graphing. I have my slope and I have my y-intercept. So I'm going to put a dot at 2 and then use my slope to graph the inequality. So I'm going to go up 1 and over 2. I know there's a point there. Up 1 over 2. I keep going that way to get a nice sense of my inequality. Since I have a less than or a greater than or equal to sign, I'm going to use a solid line. So I'm going to grab my ruler and I'm going to graph so there's the line for my inequality. Because of the greater than or equal to sign, this means that there are many points that make this statement true. So because I have a greater than sign, I'm going to shade above the line. So on my paper, I shade above the line. What this shaded region represents is that if I pick any point in this region, it's going to be a true, make this inequality a true statement. So for example, let's say I pick this point over here, which is -3, 5. Or actually, let's do -4, 5. Let's move over one space to the right. It's in the shaded region. So if I plug in x is -4 and y is 5, let's see what happens. 5 is greater than or equal to 1/2 of -4 plus 2. Half of -4 is -2. And -2 plus 2 is 0, so this is a true statement. 5 is bigger than or equal to 0. So any points in my shaded region will make this inequality true. You can test any points. Also, because of the solid line, anything that sits on the line will also make the inequality true. So let's look at the other example, example 2. Here I have y is less than -3x plus 1. So again, I graph it the same way I normally would. My y-intercept is at 1, so I'm going to put a dot at 1. And this time it tells me I go down 3 over 1. Because remember, -3 is the same thing as down 3 over 1. So I'm going to count down 3 spaces. 1, 2, 3, and over 1. 1, 2, 3, over 1. Alright, now be careful. With this one, when I draw my line, because it doesn't have the line underneath it, it's a dashed line, dotted. So I'm just going to make mine dotted. And here, less than means you shade below. So I would shade below this line, because below this line is underneath it. Alright, so anything below this line makes this inequality true. why this line is dashed is because if I pick a point on this line, it will not make this inequality true. So that's why we have a dashed line. But again, let's prove it. I'm going to pick this point right here, -2, 0. That's in the shaded region. If I plug that in, 0 is less than -2 times, -3 times -2 plus 1, because -2 is my x value and 0 is my y value. 0 is less than 6 plus 1, 0 is less than 7. It's a true statement. So when you're graphing inequalities, you follow the same steps like you're graphing lines. You find the y-intercept, and you use the slope to plot your points. If you have a greater than or equal to, or less than or equal to, you have a solid line. Less than or greater than, you have a dotted line. And then depending on the inequality, if it's less than, you shade below or under. Greater than, you shade above. And that's it for graphing inequalities. Try the practice problems.